right, 2.7 is all about parent functions for absolute values. So in other words, we're going to be transforming, moving the absolute value function. This is our parent function, okay? Every absolute value graph will start off originally looking like this, with its vertex at 0, 0, and you go over 1 up 1, go over 2 up 2, go over 3 up 3, and the same thing on the other side to make it symmetrical. All right, so this is the parent graph, and this is the equation that makes the parent graph. F of x equals the absolute value of x. Now, we're going to be doing some transformation, which let's take a look. When you transform this, you are going to see, sometimes you're going to see numbers right next to the x inside the absolute value, which will cause it to move right or left. And then sometimes you'll see numbers outside the absolute value over here that will say plus a number or minus a number, and that will cause the absolute value graph to move up or down. So this is what we're going to take a look at. Look at this. Y equals absolute value of x plus 4, absolute value bar, minus 2. The plus 4 being inside the absolute value bar is right next to the x. That will cause it to move to the left 4 spaces. And over here to the right where it says outside the absolute value, it says minus 2, that's going to cause the graph to move down 2. So let's take a look. That means that the vertex is going to be negative 4, negative 2. And the reason it's negative 4 instead of a positive 4, see this original standard format of it has minus h, and you have, if you put a minus a negative 4, you get a plus 4. That's why. All right, let's take a look. Here's the graph. Notice how we moved to the left 4 and down 2. We put our vertex, and it looks exactly like the blue original parent function, but it's just been moved, transformed, translated to the left 4 and down 2. And that's because we added in the plus 4 and the minus 2 instead of just y equals absolute value of x. All right. Now, the general rules are, in order for it to stretch, you are going to see a number out in front of the absolute value. And the number will be a whole number greater than 0. I'm sorry, greater than 1. Now, if you get a fraction outside there, it will become more narrow. And if you get a negative number, it will become more narrow. Let's take a look at what that actually means. Here we have a graph, y equals 1/2 absolute value of x. And then we have y equals negative 3 absolute value of x. And let's see what happens. Now, the original graph, here's the parent graph in blue. Now, when you do 1/2 of x, see how that half, it's going to cause it to what we call compress. And it's going to be considered a vertical shrink because it's moving away from the y-axis. See how the red graph here? All the y values became 1/2 of what they were in the blue graph. So what happens is it goes away from the y-axis, and so that's considered a shrink. Okay, so anytime you have this fraction out in front of the absolute values, it's considered a vertical shrink. All right, now let's take a look at what happens for part B here. This next question is y equals negative 3 absolute value of x. What you're going to see is it's going to reflect over the x-axis. The negative caused it to flip over. The 3 causes it to stretch out, get closer to the y-axis, because you're taking all the y values from the blue and multiplying by a negative 3. It is stretched by a factor of negative 3. Oh, now this really gets complicated. Check this out. Okay, we take a look at the original graph would be y equals absolute value of x. Now look what they added in here. They put a negative 1, which means it would cause it to go right 1. The positive 3 would mean it goes up 3. And then this negative 2 would cause it to flip over the x-axis. So let's take a look at what this actually does. Now your actual vertex is going to be at 1, 3. It's always opposite of this and this. Okay, so 1, 3. Now, so your vertex now is at 1, 3. And the negative caused it to flip upside down. Here's your parent graph in blue. Then -2 causes it to stretch. So all the y values on the blue, not only do they move over to the right and up, they also get multiplied by a -2, which results in this graph. All right. And they just tell you about how to graph it. Okay, so I would like you to take a look at this idea and try it out on your own. It says graph the function, compare the graph with the graph of y equals absolute value of x, so the parent graph. So I would like you to try to figure out what's going to happen to this graph when it has this equation. Pause your video, give it a try. Welcome back. Now the vertex is going to be at +2, +5. And see, it's over 2, up 5. By the way, the graph is based on 2s. And of course, you write the graph is translated to the right 2 and up 5. Always opposite. X's are rebels. They always want to be opposite of what you see. All right, give this graph a try. Graph the function, compare the graph with the graph of y equals absolute value of x, the parent graph. Notice it has a 1/4. Okay, pause your video, give it a try. Welcome back. What did the 1/4 do? The 1/4 will cause this graph to shrink because it's less than 1, which means it will become wide. Woo, look at how wide it gets. The vertex is still at 0, 0, because look, there's nothing in with the x, nothing over to the right. The vertex is still 0, 0. But all the y values got multiplied by 1/4, so it became closer to the x-axis. That's a vertical shrink. Here's another graph for you to try. Pause your video, give this one a try. Welcome back. Your vertex is going to be at -1, -2, and it's going to flip over the x-axis because it's going to be multiplied by a -3. So here you go. The graph is reflected over the x-axis, stretched by a factor of 3, translated left 1 unit and down 2 units. So left 1 unit, down 2 units is from that information. Stretched by a factor of 3 right here. And the negative says it's going to reflect over the x-axis. That's where we're getting all this information. Now, in order to graph these, all you have to do is just do the traditional x and y table. For example, let me get my little pen out here, because we haven't been really doing that, but I can show you the long process. You could just go x, y, 2, just like when you were in elementary school. And let's say we put in a 1. Put a 1 in here. 1 plus 1 is 2. 2 times -3 is -6, and -2. Okay, so you would get a -8. So look at 1, -8. Yep, there you are. All right, so you could, and then you could put, for example, let's say we have a -1. We place it in. That's the point right there. -1 plus 1 is 0. 0 times -3 is 0. -2 is -2. And so we have 1, -1, -2. And oh, by the way, I forgot to do 1, 8. There we go, -8. And of course, there's symmetry, so we can automatically do this one. Now, let's say we had a 0 for your x value, because notice we have 0. Let's put 0 in. 0 plus 1 is 1. 1 times -3 is -3. -3 minus the 2 makes it -5. So 0, -5, right there. And you'd have symmetry, so you could put it right there. All right. So that's the long way to do it. Okay, we're going to stop there for tonight, and I will see you all tomorrow.